Hello friends, today in chemical properties of the alkenes, I will explain you electrophilic addition. You know that carbon-carbon having double bond in which one is sigma bond and other is pi bond. And you know pi bond is a weak bond. That's why alkenes they are more reactive as compared to the alkanes. Now, how this electrophilic addition takes place? You see, in the case of the pi bond, which form a cloud around the sigma bond, and it is a weak bond. Now, electrophilic reagent means, you see, pi bond is a rich electron bond, and electrophilic reagents are the reagents which are in search of the electrons, or they are attracted toward the electrons, or they are in deficient of the electrons. So what happens in the case of the electrophilic reagents? First, when a electrophilic reagent come close to the pi bond, what happens? The electrophilic reagent polarized, and the atom nearest to the pi bond gets the positive charge and the other atom gets the negative charge. Again listen, whenever electrophilic reagent come closer to the pi bond, there is a repulsion and the electrophilic reagent is polarized. The atom nearest to the pi bond become positive charge and the other atom become the negative charge. Now this is the first step. In second step, what happened? In the case of the ethylene, the electron pair is shifted towards the one of the carbon atom, and then polarized reagent, suppose B and A, where A is positive, B is negative, and here in the case of the ethylene, this pi bond shifted towards the one carbon atom and it become enriched carbon atom. Listen, when the pi electrons pair shifted towards the one of the carbon atom, it become enriched of the electrons. So the atom A, which is positive in nature, comes to the carbon atom which is enriched of the electron and it forms a carbocation. Again listen, this pi bond, electron of the pi bond, they are shifted towards the one of the carbon atom and it becomes enriched of the electrons. So the atom A, which is positive in nature, joins this carbon atom that is enriched of the electrons and it forms a carbocation. Now this carbocation, this other carbon atom become deficit of the electron, that is positive charge. Here B atom of the electrophilic reagent which become negative in charge joins the B and addition of the electrophilic reagent takes place. This is the mechanism. Now we take an example of the HBr reacts with ethylene. Same thing, HBr polarized and it forms the H positive and the Br negative, and in the case of the ethylene, pi electrons shifted towards one of the carbon atom which become carbocation and then addition of the H plus bromine negative takes place and it forms the HBr added on the ethylene. Now it is the bromoethane. Now the second example, if we take the addition of the bromine or the chlorine. You know, this bromine molecule, it is covalent in nature, and we say that the bond in between the bromine atoms, that is a covalent bond, and the electrons, they are at equal distance from both the atoms. First, what happened in the same way, this bromine molecule polarized. Same case, here bromine molecule polarized and breaks into the bromine positive and the bromine negative. It means polarization, that is shared pair electron is shifted towards one of the atom. So it is polarized, and in the case of the ethylene, this pi bond electron shifted toward one of the carbon atom, that is the carbocation, and then addition of the bromine molecule takes place. It forms the 1,2-dibromoethane. So this is the simple reaction which I show it, that bromine reacts with ethylene and form the 1,2-dibromoethane, but the mechanism is same, that is bromine molecule first polarized. Now in the case of the addition of bromine, a transbromination takes place. It's very important. Transbromination takes place, that is a trans isomer. Listen, what happens? First, this bromine polarized, and one of the bromine atom joins with the pi bond and form a cyclic bromonium ion. Listen, bromine, one of the polarized atom, attached to the pi bond to form the cyclic bromonium ion. This is on one side. Now what happens again? Second bromine atom on the other side reacts the carbon to form the trans bromo product. First, what happened? Bromine atom reacts with pi bond to form the cyclic bromonium ion, and the cyclic bromonium ion on the opposite side, again second bromine atom reacts and form the trans product. It is very important how the trans product of the bromine takes place. So today I explained you the electrophilic addition. Please go through my videos. If you like, please share and subscribe. In my next video, I will explain you more properties of the alkenes, that is the chemical reaction. Thanks very much.